Hello. This video will show you how to use the load balancer to spread your application's client connections over multiple application server instances. Now, the application server is used to run your programs in a thin client or distributed environment, and it's included with your purchase of isCOBOL's runtimes. The load balancer is an add-on product to the application server. It acts as a gatekeeper for multiple application server instances. It redirects client traffic to the server that will best accommodate it. Though the load balancer is usually used in thin client environments, remote calls are also supported. When you use isCOBOL remote code prefix, the runtime will look for classes in the current directory and the class path directories, and then the code prefix, and then the remote code prefix. This remote call will use the application server, and a load balancer distributes the load on the application server that these calls generate. As I said, the most common usage of the load balancer is the application server. Now, each application server instance runs in a separate memory area, and each thin client connection runs in a thread in those areas. So you can use the load balancer to distribute the load of thin client connections between two or more application server instances. Now, you might do this because you have a large number of thin client connections, or maybe your application is process intensive. Another less common use is as a fail-safe for a server or a service that goes down. The load balancer will redirect traffic automatically to either another physical server or to an alternate application server process. But there is an alternative method to handle this second case as failsafe. You can start the thin client with multiple host name port designations. The thin client will try the first combination, and if it doesn't succeed, it tries the second, etc., etc. There's a couple of examples on the screen, and if you want more information, it's in the documentation. So here's a few things to know about the load balancer. After connecting a thin client session, the load balancer is done, and the thin client and the application server work together. So if you shut down the load balancer, it doesn't affect the existing running thin clients. The load balancer start command requires a configuration file with a list of the host name and port connections to redirect the traffic to. This configuration file also has to have the load balancer license in it. It's the only product that requires its license in its own configuration file. When a load balancer or application server service is closed, the TCP connection sometimes stays in the timeout state for a while, depending on the operating system settings. Using the -force on the starting command line will let the services start even if the port or the socket is in a wait status. By default, the load balancer checks the connections to each server every 60 seconds, and then it waits 60 seconds for a response. If it doesn't get a response, it will assume that the server is unavailable, and it won't send client connections to it. It cycles through every server one at a time, so if you have 5 servers, it will take 5 minutes to check every one. But you can change the default times with 2 configuration variables added to the properties file. The load balancer will continue to check the server and will pick it up again when it's started. And finally, if you have your own key store or trust store for SSL security, it can be used with the load balancer just as it can with the application server. So let's take a look at a simple case of a load balancer setup. On my Linux server, I have 2 application server instances started, one on port 1090 and another on port 1091. And those are the 2 that I want the load balancer to send my clients to. Let's take a look at my properties file. I have the host name and port that I want to start my load balancer on. The port is the default, 10999, the same as the application server's default. I have my logging turned on, just for the purposes of this demo. And I have my list of 2 servers, server 1 and server 2, with the host name, the port number, and the maximum number of users. I've changed the 60-second interval for checking and for timeout to 5 and 1. And I've included my license here in this file as required. To start the load balancer, I'm running isCBalancer space -force. That's the one I talked about earlier to force it to start if the TCP is in time wait. And then the name of my configuration file here. So let's run that start script. And the load balancer is started on port 10999. This is my IP address. And these are the two servers that it's going to be sending users to. Now in this case, I started the application server first, but the order doesn't matter. So let's take a look at what happens when an application server goes down. I'm going to stop the one running on port 1090. And remember, I set the configuration to check every 5 seconds. So it did, and it found that it could not connect to port 1090. And if I restart it, 5 seconds goes by, and it pinged it again and found that it was back. So it reconnected to it. So now let's connect a couple of clients. I'm on my laptop as a client, and the first thing I want to do is look at the administrative panel for each port. Now let's connect one client. And I'll minimize that. And we'll update our panels. And we can see that the client that I just started was redirected to port 1091. Let's do another one. Refresh the panels, and I see that the second instance has gone to port 1090. So now I have one running for each one. If I were to run a third and refresh, that brought it to port 1091. And this is my fourth instance. And you can see it sent it to port 1090, so it evened out the load. So there's a quick look at the load balancer. I hope you give it a try. If you have any questions, you can contact us at support@variant.com. Thank you.